Alright, good day. So what I would like to do next is introduce you to graphing. Now you'd have done graphing before, so it's really a recap and a review instead of an introduction. But at some point for statistics and later on topics, transformations, coordinate geometry, some functions, you would have to know how to graph or at least read information off a graph, which is something they test for CXC and good general knowledge to have as well. So one of the main things to keep in mind when you're doing a graph, points on a graph, and we'll look at some graphs just now, will always be written in the form xy, and this is very important to know what the points on the graph going to look like because they're directly related to what the graph itself going to look like. So I have some different graphs here. This one, and again, just in case we don't have graph page, we'll accommodate for that later on. So we have a graph page here. Sometimes the graph might be split in some kind of plus formation, as you can see. So that's if you have positive values and negative values. We're not going to come to this graph yet, but we will have it at some point. We're looking at statistical graphs right now, and the nice thing about statistical graphs, they're not going to be plus shaped like this, because you realize this have a kind of plus shape going on. You're going to be L shaped because you really don't get negative components in your statistical data at this level. So the graph going to be L shaped. Now I know a lot of you probably don't have graph paper. However, I did leave packages with certain things in it that you'll see keep popping up. Some of the sheets that we use in multiple choice papers and so on, I left those in the office. You could always go and take a look at those. But if we do have graph paper and can't make it to the office, you could just do a quick sketch just to get the idea, and then later on we could work with proper graphs whenever we get a chance. So all I'm doing is using my ruler, and I just grade it off. I'm using the actual lines from the book, but then I just use a marking on my ruler to make sure it evenly spaced, and that's my graph. So to get back to this point xy, let me see where those x and y is coming out from. So the x, which is your first number, talks about this line here. So the x is what we call the horizontal axis, meaning it lies flat. So that's where that x value or x number going to come out from. It's going to come out from this line because it's numbers we're dealing with here. And the vertical line, we call that the y-axis, or vertical meaning upright, axis horizontal means it lying flat like that. So that's where those two numbers come out from. And we're going to fill in the scale after, because that's something important for your graph as well. Now to keep in mind for the scale gets a bit tricky sometimes. Now it could be very simple, like in this example we're going to look at, and in one of the others it might be a little more difficult. So the scale is normally given, so they usually tell you what they want the scale to be, or sometimes they give you the graph and you just have to fill in stuff. And it's not always going to be the same for both axes. So let me look at how they will present a scale if you have to do it from scratch for yourself. So we have here, let 1 centimeter represent 1 unit on the x-axis, and 1 centimeter represent 1 unit on the y-axis. So the scale is the same for both of them. So let me see what that means. So 1 centimeter in terms of the graph page, I try to make it as close to it as possible here. 1 centimeter is how much a graph page will be split up into anyway, and we'll look at one in a better graph in a little while. 1 centimeter represents 1 unit, means if I starting at 0, every block are increasing by how much ever they tell me to increase by. They tell me to increase by 1 unit. So 2, 3, 4. So this increasing in ones because they say every 1 centimeter spacing are increasing by 1 unit. That's how we read off that scale. We'll stop at 10. Same idea here. Since it's the same scale, every 1 centimeter unit, we're going to increase by 1. And again, any question, they will give you how much it goes up to. So once we have our scale and we plot axes, now we could actually plot points. So again, to plot a point, we have to come back to this and combine it with what we saw before. So a graph going to be in the form, a point going to be in the form x first, y after. Think of the order in the alphabet. So all I have to do if I want to plot this point A, we calling it on my graph, I find x is 2 on my graph. So to find x is 2, I need to look at the x-axis, find x is 2. So this is x is 2 running up and down like that. Again, you will have your lines on your graph page. I just draw a sketch to guide you. And I find x is 2. Now I'm going to find y is 5. So this is my y-axis. I find y is 5. Y is 5 running across like that. And the location where these two going to meet or bounce up, the junction there, I mark off that spot with either x or a bullseye, a dot with a circle around it. I prefer the X, but the bullseye is the other acceptable notation. They prefer not just put a dot. So if you're going to put a bullseye, it's a dot with a circle around it, or an X to mark the spot. And that's the coordinates of A. Coordinates of A, X always first, Y after. So the coordinates of A is 2, 5. Same idea now if I wanted B. Again, as my guide, I always write this X and Y to let me know that I'm looking for. X is 3, Y is 7. So I find X is 3, I find Y is 7. So X is 3, Y is 7. Both of them going to bounce up here. And again, you could use the X or the bullseye. And that's going to be my point B, 3, 7. You don't have to write back the 3, 7. I'm just showing you where the 3 and the 7 coming from. Next one, C. Again, I'm going to put X and Y. So X is 1. So 1 running up and down like that. Y is 11. So Y is 11 running across. X is 1 running up and down like that. Again, you'll have your lines in the graph paper. I just doing a quick sketch to show you. That'll be my point C. And sometimes you'll ask you with numbers with 0. When one of the points is 0, you have to be careful. That's where it gets a little bit trickier. So X is 0. This is X is 1, 2. So this is X is 0. Y is 3, so this is X is 0, just like X was 1 running up and down there. So X is 0, Y is 3, going to actually be on the axis itself. Let me do one more where I put the 0 on the other number. So let me say X is 5, Y is 0. So I find X is 5 first. X is 5 here. Y is 0, this was Y is 1, Y is 2, Y is 1, Y is 0. So Y is 0, X is 5. So you realize it's going to be on this axis this time, and that's going to be my coordinates E. So this was a pretty simple scale. I want to look at a next scale now. So again, that's it. We plot some points on the graph, and later on we could do different stuff with the points. This is just to show you how to set up your graph, how to plot the points, and where the X and Y axis coming out from. So here now we want 2 centimeters. So I'm going to use this graph here, a proper graph now, and you can see the gradations on it. 2 centimeters represent 1 unit, so different from the last one that was 1 represent 1. Here I want 2 to represent 1. So on the x-axis, again the x-axis is going to be my flat horizontal line, and the y-axis is going to be the vertical piece up here. I want 2 centimeters to represent 1 unit. Now since I actually had the graph, you realize the graph broken up into tiny blocks. Every 5 tiny blocks is 1 centimeter. So 2 centimeters will really be 10 of the tiniest blocks that you have. So 10 tiny blocks on my graph is 2 centimeters. So every 2 centimeters, if I starting at 0, they want me to increase by 1. So 2 centimeters is 2 big blocks, or 10 tiny blocks, are increasing by 1. On a continuum scale, our next 2 centimeters or our next 10 tiny blocks are increased by 1 again. So that's what my scale going to look like for the x-axis. Now the scale for the y-axis was different. Let me see what the scale for the y-axis was. 1 centimeter, again 1 big block, or in other words, since I have the little markings now, is really 5 tiny blocks. So on my y-axis, every 1, 2, 3, 4, 5 tiny blocks, I want to increase by 5. Our next 5 tiny blocks I increase by 5 again, because that's how this one increasing by 10. So that's why you need to pay attention to the scale in particular to make sure your graph look like everybody else. So in this second part here, we're moving in 5s. 20, 25, 30, 35, and so on. I'm going to stop there for now. So let me actually plot our points. If I wanted to plot some points, we're just going to pick some points. I'm going to call them X, Y, and Z this time. So let me say X is 220. Y could be 437. And Z could be 0, 15. So the first thing I'm going to do before I plot my points, I'm going to write in my little X and Y here. So I'm looking for X is 2 on the x-axis. This is where X is going to be 2. I already have my line running up this time. Y is 20. Here's Y is 20. X is 2. So Y going across here. 2 coming up here. So we're 20 and 2 going to meet. I'm going to mark off that point. That's how I label my point, and I'm calling it X. Same idea now for 437. X is 4, Y is 37. I find X is 4. But you realize now I have no exact 37. So that's why you have to know how to read in between these blocks. These blocks are going to come into play. So if 5 tiny blocks making up 5, that means this is 1, 2, 3, 4, 5. So each tiny block is 1. So this is 16, 17, 18, 19, 20. So 35, 36, 2 blocks after 35. Here going to be 37, and I want it to line up with 4. So where 37 and 4 going to line up, 35, 36, 37. That's where my point Y going to be. And now last one, just to show you, 0, 15. So x is 0. That's x is 0, x is 1, x is 2. So x is 0 running up and down like that. Y is 15 going to run across like that. So that's where my z going to be. And that's an introduction to graphing. We'll see some harder graphs later on. And again, the worksheet in school, I'll still send it virtually via email and WhatsApp as well. But that's how it's going to look for graphing for now.